times what happens with the quadratic word problems is that you're going to be looking for maximums, looking for minimums. Depending upon how the setup is, you might be factoring. Depending on how that works, you might be using your calculator, and so on and so on. And we need to learn kind of some of the vocab as you go through it. Let's see here. One of the things they talk about is it's a very simple style word problem that's quadratic, is when they talk about border of uniform width. I'm sure most of you guys have seen pictures, bless you, pictures or picture frames and stuff like that that have a border around them. Fortunately, I'm looking over there thinking I had a border on one of those, bless you, and none of mine have borders. But I know that when I go and have things framed of other stuff, I will put a border around an object. So this one is I thought it was a good one to start with. I don't know what number it is on here, but some of them are a little out of sequence as far as my slides are, but I know you guys will figure out because sometimes you read-ish. Glass window, 2 by 4. Does it matter which way is 2, which way is 4? So what we do here is we start with a diagram. And a lot of times with these things, I want to draw pictures just so we get a visual representation of what we're looking at. If this is 2 by 4, I would say 2 by 4. Then it says you have 7 square feet of clear glass to create a border of uniform width around the window. Which should the width of the border be? So we have to figure out what that looks like. Which means if you're doing a border of uniform width, you're basically going around the object with the same dimension. That's what that means. Bless you. Uniform width means the same dimension. Okay? I'm going to reset this again. And since we don't know what that value is, I call it x. And I'll show you what it's going to look like here. Sorry. I call this value x. From here to here is x. From here to here is x. There's a whole bunch of this same uniform width all the way around. And I kind of overdo it by kind of showing what it looks like. So that way you get the idea of what is the new overall length and width of the frame. If I do it this way. What did I add to both sides? X, right? I added values of x. So now my new from here to here is how much? Not 2x, 2 plus x. Yeah, it's 2 plus 1x, 1x. What's 1x plus 1x? 2x. So now 2 plus 2x. And then going this way, it is 4 plus 2x. Okay. Now, if you start to think about what you're trying to find an area of, we're trying to figure out what the dimension is of the border itself. What's the area of the picture? 8. Yeah, it's 2 by 4. So the area of the picture is 8. Now, the area of the whole thing would be this times that, right? And if I back out the picture, I would have just the area of the board. It's a shaded region problem, if you really think about it, that you guys did in geometry. So what happens is we get 2 plus 2x times the quantity 4 plus 2x. That's the area of the whole object. I need to back out the actual picture. What was the area of the picture? 8. So I back out the 8. And then this gives me this area here. What do I have to set that equal to? 7. Right. See that? Because that's how much you have to work with. You have 7 square feet of clear glass. So this is your area. This is right here. This statement is the area of the shaded region, just the border itself. And I have to set that equal to 7 to figure out what it's going to wind up being. Okay. So let me move this down a bit here. So 2 plus 2x. Okay, FOIL out. Excuse me. If I FOIL this out, we get 8, 4x, 8x, plus 4x squared minus 8 minus 7 equals 0. Reason why I brought that 7 over is because when we set up the factor and things, we always have to have a sign equal to 0 in order to solve for our zeros. Okay? So when it says solve or an equal sign, that means you factor like you would normally, and then the last step is to set those parts equal to 0. 8's drop, that's pretty quick. And then we get 4x squared plus 12x minus 7 is 0. And you're back to a factoring problem. You're back to a factoring problem. So if you factor that, what do you do? What's negative 28? You add together to get 12. 2 and 14, you said? So we get 4x squared minus 2x plus 14x minus 7. And we do a factor by grouping. Whenever you've got a positive and a negative and you're doing your factor by grouping, you don't have to do this, but I always like to put my negative value second, so that way you don't have to, remember how we always did that same change opposite when we grouped it? That way you don't have to worry about the negative doing it that way. So now you take your groups, factor out a 2x. We get a 2x minus 1. Take out a 7. Oh, whenever you guys factor via grouping, make sure you're putting this sign out there. Sometimes you guys forget that. Okay? And then that s equals 0. Are the two things in the parentheses the same thing? Yeah. So we write it down. And then what's left? What are your two zeros? Well, the one on the left is pretty quick. Add 1 divided by 2, you get half. The other one is negative 7 halves. Which of those can you use for a border? The half. That gives you your base factor. Yes, sir.
So you had the positive 12x and negative 7. How does negative 2 and 14 multiply?
What? It's 4 times negative 7.
Oh.
It's 4 times. And you were looking at it when I got down here after I factored something out. Yeah, we started with this part and we broke it into the 4 pieces.
Okay.
So we started with the 4 times 7. It's still there, but we split that middle term into those 2 pieces. Yes, ma'am. Oh, correct. What's actually happening here is you are maximizing that border by what's gonna give you the best coverage that works, and that's what we want to do. So here you wound up with your border has to be 1/2 because you can't have a border that's negative 7. Sometimes you guys will see what's that? Oh. Yeah, you'll find out real quick when you're doing some of these factoring with the quadratics, the negative answer is not going to make any sense. You know, just like, wait, how does that work? You can't have negative spacings and sizes and stuff. Right? That's kind of what we start to work with. Uniform width. Order of uniform width is a very, very common quadratic style word. Okay, not terrible. What was the next one I wanted to look at? Okay, save these. That's uniform width. Uniform width. Good morning. Please. It's uniform width. Uniform width. That's this one. We did this. Trying to figure out what side. Okay. So on that first page that I gave you guys, it's number 99 on the bottom left-hand corner there. This is another very common. I know. You guys are young. Your eyesight should be good. I mean, if you really, really, really wanted to, like I said, each one of these word problems, it starts in section 3.1, 3.2, 3.3, 3, 4, 5, 6. They're all in there. I just take them all out at once, and I think it's a little bit easier just to do it all at once as opposed to piecemealing things together.
Yes.
All right. So this, like I said, this is a very common style quadratic. You have a sales, and then you have price increases and sale figures that decrease. So as we're looking at something like this, we say a shoe store sells. I can't say that quickly. Like seashells by the seashore. A shoe store sells about 200 pairs of shoes when they charge $60 a pair. For each $1 increase in price, about 2 fewer pairs per month are sold. How much per pair should the store charge to maximize monthly revenue? What is the maximum revenue? A lot going on there. But what are the two things that they're talking about? Maximizing monthly revenue. So you have a revenue, you have a cost, and a unit. Okay. You have units per, like how many shoes you're selling, and you have a cost. Dead giveaway. It's going to look like this. We have a units and a price. What I mean by units is how many they're selling. Okay? How many they're selling. What I mean by price is what does it cost? What are they charging? That kind of idea. So as we go through this one, how many units are they selling? 200. So they're selling 200 units. At what price do they sell 200 units? 60. So if you start to look at it in terms of the quadratic, if you FOILed that out, you'd have 200 times 60, which would be their revenue for that price. Does that make sense? So those two match up. Now, they talk about when they charge $60 per pair, for each $1 increase in price, 2 fewer pairs are sold. Now, here's where this kind of gets a little muddy. What happens here is there's going to be some multiplier for each one of them. That multiplier just means the number of times something happens. So if you have if you increase the price 5 times, it would be plus 5x for each increase of 1. So they're increasing of 1. You decrease by, what was it? 2. So the other side would be minus 2. There's going to be a value of x on either side like that because that's the number of times something goes through. Okay? Does that make sense? Now, what form is this written in? Bless you. It's intercept form, isn't it? That's intercept form. Whenever you're written in intercept form, it is super fast to get your answers because what can you find in intercept form? You get your zeros, and what happens halfway between the zeros? Your axis of symmetry. What occurs at the axis of symmetry? Your vertex. What's at the vertex? Your maximum or your minimum. Sort of all this. That's why when we talked about all of these different formats of graphing and how you plot zeros, what's occurring in terms of axis of symmetry and things like that, that's why I brought all of that up and kept asking you, is it a maximum? Is it a minimum? Is it up like a cup? Is it down like a frown? Because in your minds then you were starting to think to get to this. Okay? Because if I look at this, I have zeros at what, negative 60? And here is at 100. You okay with that? Those are my zeros. All right. What's negative 60 plus 100? What's half of it? So where's your axis of symmetry? 20. My axis of symmetry occurs at 20. What's negative 60 plus 100? Remember just doing the midpoint? You went cross-eyed, that's what I was wondering. Okay. Now, if you look at the two binomials here, will this vertex be a maximum or a minimum? It's be a maximum because if you FOIL it out, you have a negative a squared. You have a negative value when you square it. So somewhere on this spot is my maximum. That means it's my biggest bang for my buck for this one. If I increase the price 20 times, I would sell so many shoes. Well, what do I do with this 20 to figure out what that value is? I put it in brackets. So in your calculators, you can do 200 minus 2 times 20 times, well, 60 plus 20. It's not terrible. What's 200 minus 40? 160. So you have 160, excuse me, and then you're multiplying that by what, 80? 8. So that value of X tells you the number of times you can increase your price. It also tells you the number of times fewer shoes would be sold. But then if you put it all together, it tells you what your revenue is. Because this is a function of revenue. That's your function of revenue. If I increase my price to $80, I maximize my profit at $12,800. I will sell 80 shoes a month, 80 pairs of shoes, at a price of, what did we say that was? 160. Or no, I'm sorry, I said that backwards, didn't I? Price of $80 and I would sell 160 shoes. Excuse me, I said that backwards. Yes, sir.
I noticed that like in the graph here, zeros are negative 60 and 100, and I was just wondering, would it be possible if you sell it for -$60 if you would make more?
Right, that's what the zero means. You make no money. You make no money. So basically, if I'm giving away shoes, am I making any money?
No.
That's exactly what that means. Because if I give away a shoe, if I give them away, I'm making no money at all. Or if I sell it for 160, nobody's gonna buy it at 160. That's what that means. If I increase the price 100 times, no one's gonna buy it. And obviously, somewhere in here is the actual line of zero. So you're never, in terms of sales figures and stuff, you're never gonna. You don't want to sell something that will cost you money. If that makes sense. There are very few items. Did we talk about commodities before? A lot of times, like Lowe's, Menards, things like that, like 2x4s, drywall. Those things are sold at a commodity price where they don't make any money on those. They're selling them at cost. If a 2x4 costs them $1.50, they're selling it for $1.50 because that's the price of things. They don't make much money on it. They make the money on nails, screws, mud, things like that. That's where the margin is. That's where they make their money. So a tub of mud might cost, you might be paying $12 for it, but they only paid $7. So they're making all their profit on it. They make a 40% markup on things like that versus 2x4s and studs. We'll go from there. Okay. Let's do one with the calculator. Those are fun. All right. So second page over on the top right-hand corner, they talk about Jackie Joyner Kersey. She was a heptathlete. That's like the 10-sport thingy in the Olympics. Heptathlon, I believe. And like I said, I kind of piecemeal through some of these things back and forth. Yes, the heptathlon during 1992, as all of you guys are well aware of the Olympics of 92. I believe it was Seoul, Korea. Yeah. Oh no, it's Spain. Sorry. I thought I didn't realize it was. I guess if I read it, I would know where it was at. So never mind. It was in Barcelona. It's not Korea. In case you guys were worried. You know, they are two different countries. They are on two different continents. Two different oceans next door. Spain, Korea. The languages are so similar. Anyway, so her throw in the shot put is one of the 7 events in the heptathlon. I thought there was 10. Oh, that did decathlon. I am SMRT. Can be modeled by the following. Blah. Where X is the shot put, its horizontal distance traveled in feet, Y is its corresponding height in feet. How long was Jackie Joyner-Kersey's throw? Okay. Does anybody know what a shot put looks like? Okay. It's like a little small cannonball thing that they spin around really, really fast. They throw it super hard. They do that with shot put too. That's what you gotta do. Putting here, they spin around and push.
Yeah, it's for momentum.
They do the same thing with that. So here's your shot put. It's not to scale. And obviously you go down and start spinning and spinning, and they go and do that. I threw it really hard on the ground. If I throw you really hard on the ground, you might bounce. It's just like, what? It's like, anyway, so what I want you guys to think about is, why is it a negative? What? Again, watch. Why is it a negative? It's down, isn't it? It starts down. It goes up and comes down. It's a negative. What does the 5.5? What's the 5.5 start mean? Perfect. Yep, exactly. It's where she starts it from. She's starting to throw it 5.5 feet off the ground. So if you think about the quadratic in this case, you have an initial height. The initial height of her throwing the ball is 5.5 feet off the ground. That's what that stands for. That's what that 5.5 is. Now, if you really want to get fancy here, it's starting here at 5.5. It's going to go up and hit the ground, right? Somewhere along the line, it reaches its maximum height. What goes up must come down. When it hits the ground, it's its what? It's its zero. It's its zero. But is there a minimum when you have that? Now, according. No, I know what you mean by that, but do you guys all agree that this still is a continuous function infinitely in both directions, going face downward, right? But you have to think about it in terms of real world application. Perfect. Started at 5.5 feet up off the ground. It went, it stopped. What do you think is so funny? Here, you do it. Why not? Then you can see it's fun. Stand up and do the whole motion. Go. Because that's what they do. Why not? Let's do the whole thing. I want you all the way down.
Let's see what that thing is.
So anyway, here's what we can do.
I heard lock him out, I'm like, great.
Here's what I want you to do. Take out your calculators. I want to show you guys how the modeling stuff and how you can use the calculator to figure out a lot of things. Those are heavy. Go to the y equals. And let's type that in. It was negative 0.0241 x squared plus x plus 5.5. Okay? What's that? No. It says x. Okay? That's okay. You gotta change our windows now. So now, here's the deal. In your calculator right now, it doesn't show the whole graph, does it? We need to figure this out. So what we have to do is we have to adjust the window. This is where playing around with the window settings is going to be really important. So there's a button on the calculator that says window. Right now you are probably at a 10 by 10 window screen. Okay? Now, we really don't care about anything negative y. And we could probably go to we don't really care about anything negative for x. So we can do our x minimum at 0. Our x maximum, we're trying to figure out how far she threw it. Remember, the horizontal distance is the value of x. The vertical distance was the value of y. And that's why at 5.5, it's 0. At 0 for x, that's the y-intercept. That's where it starts at. So we just have to take a guess. How far do you think she threw a shot put? 20 feet, 30 feet, 100 feet? I don't know. Or 60? Maybe. Let's just say we didn't know how to do all that yet. We just put 50 in. We're just trying to guess and check. I'm going to get rid of my y minimum because I don't care. And I just hit a graph again. Oh, it hit. Put it off. Hello! Good morning! Where are you going?
You didn't win anything.
Now, I want to see how high up it went, though. So I need to adjust that window as well. Okay? Because I'm going to show you how a little trick how something works. Let's change our window to our height. Let's say 25, maybe. And hit graph again. All right, cool. There's her shot put. Why not? Ah.
You're having issues.
So here's what happens. That's a 0, isn't it? Okay. That's a maximum, isn't it? Okay. We know there's actually some buttons that'll help us figure out both. Second, calculate. The button says trace. It's one right next to graph. Everybody see that? First thing we're going to find is the 0. Okay. First thing we're going to find is the 0. So hit option 2 or just scroll over it and hit enter. Now the calculator does a couple of things. It asks about boundaries. It says left-hand boundary, then we're going to find a right-hand boundary. So I don't know where your cursor is on your screen, so everybody's a little bit different. What we're going to do is we're going to move this cursor, just by using the arrows, close to where it crosses the axis. And I apologize, mine takes forever on the screen. Yours is much easier. So you want to get close to it. Now, we all agree that the value of y at some point is going to go negative when it crosses the axis. So what we do is we put a left boundary very close to 0, hit enter, and then it asks for a right boundary. I'm explaining what's happening. What's happening here is on the graph, you're figuring out left of where it crosses, right of where it crosses. You figure, because what the calculator does, it's going to do a bunch of calculations for all values of x between the two settings that you give, and it's going to figure out where it crosses, or it's 0. So then you just hit it and you go to the right of it, so you get negative. See how my y value jumped to negative? That means I know it crossed the axis somewhere, and I'm going to hit enter again. Then it says guess. Potato. I don't know. I have no idea why it says guess. I've never figured out why it says guess, but it says guess in the sequence. So you just hit enter. There's your 0. How far did she throw it? 46.41, was it meters or feet? Feet. That's what the calculator will do for you. Yes, ma'am. Okay, on the window tab, what I did is I set it up as a 0 by 50 for X and 0 by 25 for Y. When you're messing with your windows, you're going to just be kind of moving it around to try to get the best idea of where it could be. It takes a little bit of time to play with the window. Okay, I'll be there in a second, okay? Now, go back to your graph again. I'm going to show you how to calculate a maximum. The same process. Hit second, calculate. There's an option there for maximum. You don't want to find a minimum here because it's not a minimum curve, it's a maximum curve. So we hit the option 4. Again, it's going to ask us for a left-hand boundary and a right-hand boundary. Right now, my cursor is somewhere down here because that's where it says for the y value. So I need to move it back. Nice up. And I'm going to be, and this is really easy to see what it's doing here for a left-hand and a right-hand boundary. I'm going to be to the left of where I think the curve hits the top. I'm going to hit enter. And then I'm going to go to the right of the curve where I think it hits the top. And hit enter. Again, orange. Oh. There's my maximum. The maximum height that it reached was 20.75 feet. That's a lot. And it occurred, I'm sorry, after 20 feet out, it was 15.87 feet up in the air. That's how you calculate those things through. Now, hit enter one more time. Whenever it says guess, it just means it. And your rounding, depending upon where you set your parameters, you're going to be off a couple hundredths or thousandths or something like that versus what I get. It's all close. Okay? A lot of these will be very, very close, especially when you get these weird functions. Did it work then? Cool. All right. Window. If you get to the point where everything's all messed up, reset. You know how to do that? Second plus sign, 712. It's kind of like, you know how you have the Control Alt Delete and Achu button to restart your computer type thing? If you ever have to do that with these calculators and you can't figure out what happened to your window, you can't find anything, and you just want to start over, you hit second plus, and then 712, then you hit second plus 722. That resets and restores. Those are the sequencing of the buttons that press for reset and restore. Just in case, because it's going to happen where you're doing some of these problems with the window, it just gets all messed up, you're not sure where it goes, but that's what you would do. Okay. Let's see, what was the other one? Yep. Got that one, that one. That one's okay. Okay. So, the ones I want you to try this evening. The ones I want you to try this evening. On the front page, excuse me. There's There's 98. 100, 101, 90. And then the second page. Okay. I try to make sure the numbers and stuff are on there. We'll talk about initial velocities and things like that tomorrow. But what I said, yes, ma'am. They are all calculatorable. I like that word. That's very good. I like that. The one where we did, even the one that we did with the zeros, it's easier to do it without. You can do that one with the calculator, find your zeros, find the maximum, and do all that as well. But when you understand what is occurring, it's a little bit faster than trying to go through on the calculator. But yeah, these are all calculatorable. All right, give those a shot. We'll go through some more of these tomorrow. I've got more initial. We'll talk about what it means as far as writing a model out in terms of what's called initial velocity. This is like a physics stuff. Those are pretty simple. They're all kind of the same about. It's not just gravity. You know, it's important. And then we'll do some more of those tomorrow. Then probably Wednesday. Hopefully by the end of this. Then on Thursday, we'll start doing what's called completing the square, which again is another way of factoring and solving stuff, but it's extremely procedural. And I know how much you guys like to follow a procedure and replicate a process versus having to have to think. But a lot of this mixes up, okay? Yes, sir. I've got 3 people that has to take it still, and then hopefully tomorrow, Wednesday at the very latest. All right. Yeah, and I'm sorry, I will be down at Huntley today, so I won't be here for Flex. Murphy's Law.